Good afternoon, everyone. I am Dr. HimaBindhu from the Department of Mechanical Engineering, and I'll be dealing with subject robotics. And my today's topic is path planning. Right? In the last class, we have studied about the trajectory planning. What was the importance of trajectory planning? How it works in robotics? And what are the various applications of the trajectory planning we have seen? Right? In the same way, in today's class, we will be discussing about the path planning. What do we mean by path planning? What is the difference between the trajectory planning and path planning? Yes, as we all know, as we've discussed earlier, the trajectory planning is nothing but the robot has to it has to decide its path without touching the obstacles, that's escaping from the obstacles, and move from one end to the other end. That is, from the starting point to the ending point. Whereas in the trajectory planning, the robot has to initially plan the movement of the robot has to be done in prior. That is, before the movement of the robot is to be done, the path planning has to be done, where the robot has to select the possible shortest distance for moving from the starting position to the end position. Right? That is, the path planning is used to the autonomous vehicles, or we also can tell it is used for the robots to find the possible shortest distance to move from the start position to the end position by not touching any particular obstacles or by mostly free path obstacles way. Right? That is, in between the path, there should not be any sort of obstacles, and if there are any obstacles, the robot has to find the shortest possible distance to move from the initial position to the final position. That is, it has to plan its position and orientation, or it has to plan its waypoints to reach the final destination. It is generally the need of this particular path planning is to find the collision free path for the robot, as I've told you, from the starting point to the end point, or we can say as a goal configuration. Right? So it has to plan its path by a collision free robot movement. Right? So this particular type of the path planning is one of the oldest fundamental problem in robotics. Right? So in order to generalize this particular point, we have come across a project planning where initially a path planning algorithm would guarantee to find a collision free path whenever there is a path existence. That is, in order to find out the possible shortest distance for the movement of the robot to be done within its particular surrounding or environment, an algorithm was been written, and based upon that particular algorithm, the robot's movement would be done. So here in the path planning, as I've told you, if for example, we have a robot being placed here, right? We have a robot being placed, and this particular robot has to move from the starting point, and this is the ending point, and in between we have few obstacles. Though this particular robot has to move to the end position to the shortest possible point. If we are going across this, it comes under the longest distance, right? Whereas if the robot is directly moving like this, it is the shortest possible distance. So generally, the planning of the path has to be done by selecting the shortest possible point by getting free from the obstacles in between where the robot is moving from the initial to the final point. So generally, this particular path planning essential in the field of robotics, as I told you, it is very important in robotics, where it requires a fast algorithm to be developed. Right? If we are developing an algorithm only, the movement of the robot can be done at a shortest path. Right? So here we have two types of path plannings. One is the global path planning and the local path planning. That is, here as we can see, the path planning is being divided into two types. One is the global path planning and the other is the local path planning. So here what happens? What do we mean by global path planning and what do you mean by the local path planning? Here the global path planning means the robot has to decide its path initially before the movement of the robot is done. Right? Before the movement of the robot only, the robot has to analyze its path. When it is moving from one position to the other position, it should analyze its path by seeing if it is having any sort of obstacles in between, or is it having a safetiest and this very speediest path to travel from one point to the other. That is, it has to analyze its path before the commencement of the movement of the robot. That is known as a global path planning. That is, it should compute the complete path before providing a solution. Right? In a global path planning, the robot has to compute its complete path before it provides a solution, before it has a movement. Right? That is, this particular type of the method requires knowledge. As I've told you, it has to analyze. It should require a prior knowledge. The robot has to require a prior knowledge of its environment. That is, when the robot is moving within an industry, it should have the knowledge of that particular industry, where the objects are being placed, where are the obstacles being placed, from where the robot has to move, and up to what distance it has to travel. So, in that particular distance, in between, does that particular robot come across any obstacles? Or what is the possible shortest distance it can travel from the initial position to the final destination? So it should have a prior knowledge, that is known as a global path planning. That is, in any industry, when work has to be done fastly, the robot should plan its path with its knowledge about the environment condition, about its surrounding, and it should priorly plan its path. That is, using this particular environmental knowledge, it will create the simulated environment where the method can plan a path. That is where a planning of the path can be done. If it is having the knowledge of the environment priorly, accordingly it can plan its path. In the same way, when we come across the local path planning, here the difference between global and local is that in global, the robot has to plan its movement initially, priorly, before reaching to the destination. It should know about it should have a knowledge of its environment before starting. Whereas in local path planning, there we don't require any pre-planning to be done. Right? The robot doesn't require any pre-planning to be done to move from the initial position to the final goal position. That is final result position. That is, the robot will be making its path planning as per the movement of the robot being done. Right? As per the movement of the robot being done, the robot will change its path planning depending upon the obstacles, depending upon the surrounding environment. It will change its planning. That is, here in the local path planning, generally refers to the method that takes in the information from the surrounding in order to generate a simulated field where a path can be found. That is, when it is moving from the initial position to the final position also, it can plan its destination accordingly. Whereas in global, the planning should be done priorly before. That is, here no complete path is being calculated prior to the initial of the robot movement. That is, the path planning will not be done initially where the robot movement will be done. So this particular type of the path to be found is the real-time application. Generally, for example, we have Google Maps. Right? In Google Maps, initially we plan some particular path. We give some destination to that particular Google Map from the start position. So it gives us the global planning initially, right? It gives us the global planning initially, and it also shows us the shortest possible distance, and it also gives us the longest possible distance, and we accurately select the shortest possible distance, and it gives us the time calculation also from the start point to the end point. So that is the prior planning, path planning being done. That is called as a global path planning. Whereas when the vehicle is moving, the route will be changed. Right? In Google Maps, what happens when the vehicle is moving? The path planning will initially be changed depending upon the traffic, or depending upon the road construction, or depending upon the environmental condition being applied in that particular surrounded area. The Google Maps, what it does, it changes its path. So that is known as local path planning. That is when there is movement of the robo being done, and depending upon the environmental conditions, depending upon the dynamic obstacles, or depending upon the static obstacles, or depending upon the surrounding of the particular industry, or depending upon the surrounding of the particular company, the local path planning will be done instantly. Right? The path planning will be done instantly. So that particular type of the planning is known as local path planning. Right? So here in path planning, we have two types of path planning. One is the global path planning, and the second one is the local path planning. Right? So next, coming to the strategies. What do we mean by strategy? There will be various strategies for any particular planning. So accordingly, there are few of the strategies which a robo has to maintain when a path planning will be constrained, when a path planning is to be done. That is, generally, the first constraint is that it should have offline or an online path planning with collision avoid. In order to avoid the collision, the particular robo should undergo an offline or an online path planning for a signed path. For any particular assigned path, we should have an offline and an online path planning to be done to avoid the collision. Whereas the second one, important one, is that without any particular path constraints or without any particular path sign, how is that particular planning done? Right? How are we doing that planning without constraining any path constraints or without any path signals? How we do? How is the path planning strategy done? So generally, this particular type of the path planning will be done based on the online obstacle, that is position control. Based on the control on the position or the motion with an online obstacle identification and the collision avoidance, we do this particular path planning. Right? That is the position controlled motion with online obstacles identified and collision avoidance, we will be doing one of the path planning strategy. Whereas coming to the third point, that is, this is for the online. Whereas when we come across offline planning, what happens? Collisions are possible. Right? Here collisions will be possible. That is, priorly, when we are doing a prior planning, that is when we are doing an offline planning, we can come across the collisions, and accordingly we can plan the path. So that path constraint of online path planning or an offline path planning through the signed path, that is to the assigned path from where the robo has to move, at what constraint, at what fixed position the robot has to move. When we are coming across, we can come across the possible collisions. If we don't know all these details, then what happens? We come across the collisions. right? So the last one is the position control motion without obstacle identification. That is, positions are again here possible when we don't know about the identification of the obstacles. In that position also we come across the collisions. So that is also one of the strategy for planning the path. And next, the main path planning for the robots are as follows. That is, these are the few main path planning tasks to be followed by the robot. One is the grasping and releasing the object. That is, when any particular robot grasps the object or releases the object, it should know where it is grasping and where it is releasing. It should have its planning. It should have, when a path planning task is being given to the robot, it should know what is the input and where the output has to be done. That is, it should have a grasping and a releasing object planning. Next, moving from one place to other. That is, this is the start position. And for example, this is the end position. The robot has to know where it has to start and where it has to end, and what is the path it needs to travel. It should have that, it should know. That is, moving from one place to the other place, the robot has to have its initial planning of the path. Next, moving on to the third one is following the previous specified path. We can also come across following the previous specified path. For example, already that particular task has been done 2 or 3 times. So directly the robot can follow that path without changing any of the direction, without changing any of its path planning. It can follow blindly the previous path, right? And next one, following moving objects. By following the moving objects, that is, when the objects within the particular environment is being moving, we need to follow that objects, where it is moving, how it is moving, and we need to do the path planning for the robot. Next is the working with other manipulators. Right? When the robot is working with other manipulators, it should have an idea of its planning, how it is moving, how the other manipulator is being moving, at what distance it is moving, at what constant it is moving, and according to that knowledge, we have to do our planning. Robot has to do its planning. And next is exercising its forces. That is, by pushing, pulling, or holding also it can plan. And next is the torque, right? Force and torque come under the motion analysis. So, by determining the dynamic motion analysis also, the path planning of the robot can be done. Next, this is the figure. That is, this is one of the example how the robot has to do its path planning. For example, here we have 2 figures, figure 1 and figure 2. So, in figure 1, what can we observe? These are the obstacles which we are having, right? 1, 2, 3, 4. These are the 4 obstacles which we are having. And the robot is making its path planning from 1 to 2. And then towards 3, it is coming and it is holding one object. And then it is coming and it will hold this particular object, right? So, this particular movement, when it is going, generally what we need to plan to catch the red ball, right? The plan is to catch the red ball. That is, the robot have to move the red ball. So, in figure 1, when the robot is moving from the initial position 1 to catch the red ball, what is happening? It is moving from 1 to 2 to 3, and then finally it is coming to point 4. So, what is happening? The travel time is increasing to move from all these particular paths, as well as the robot is increasing its path, right? The robot is increasing its path distance. Whereas in figure 2, if you see, since we need to catch the red ball, the robot is directly moving in the shortest possible distance, right? The robot is moving in the shortest possible distance to catch the red ball. Our main motive is to catch the red ball, not the green ball, right? So, directly the robot is moving from the initial position 1 and directly it is going and catching the red ball, where it is searching for the possible shortest distance, right? That is, this particular type of the robo, when it is moving, we can call it as a global path planning. Here we can call this as a global path planning because it is observing. The robot's algorithm or the robot sensor is observing where the ball is placed, at what distance it is placed, and what is the shortest possible path which I can cover, and accordingly it is moving. It is priorly it is calculating its path. Whereas here in figure 1, what is happening? It is coming across local path planning, right? That is, it is starting its movement. The movement of the robo is starting, and according to the movement of the robo, the path will be changing. Right, according to the movement of the robo, the path will be changing. So this is comes under local path planning. So generally in path planning, we need to see the shortest possible distance which a robot can travel to reach its required destination, desired destination. Clear? Next, coming to the types of algorithms which can be inserted in the robot. What are the different types of path planning algorithms based on which the robot can work? So, what are the applications of these particular algorithms? We will see. So, generally, we have three types of algorithms. One is the graph-based algorithm, one is the sampling-based algorithm, and one is the optimization-based algorithm. Graph-based, sampling based, and one is the optimization based algorithm. Again, this particular graph based algorithm has been divided into two types. One is the Dijkstrain algorithm and one is the A-star algorithm. That is, here this particular type, the first type of the algorithm is used to find the shortest path, right? This particular type of the algorithm is used to find the shortest path with the help of a graph. Right, that this generally we call it as a static environment. Whereas when we come across A-stat algorithm, here this particular A-stat algorithm is based on the balance optimality. Right, based on the balance optimality and computational speed, this particular algorithm will be working rather than the weighted graph type. Whereas when we come across the sampling based algorithm, here again this is divided again into two types. That is, one is PRM and RRT. What do we mean by PRM? Probabilistic roadmaps, and the next one is rapidly exploring random trees. That is, again here what we do based on the construction, based on the constraints of the roadmaps, the algorithm will be written, and the path planning should be based on that particular roadmaps and possible paths being done where it uses a C shape, right? Where it is using a C shape movement of the robo from initial to the final destination. Whereas in RRT, that is rapidly exploring random trees, what is happening? We use the high dimensional spaces. Right, by using the high dimensional spaces of building the tree, we explore the algorithm. Again, this is also in the C shape. So this is one type of the algorithm for path planning. Next is the optimization based algorithm. Again, this is also divided into two types: trajectory optimization and hybrid approaches. Right, we have two types of algorithm. One is the trajectory and the next is the hybrid approaches. So what is happening in trajectory? With the help of the mathematical optimization technique, we calculate the shortest and smoothest possible distance. Right, we will be calculating the shortest, as well as we will be calculating the smoothest. Smoothest means which is coming across one constraint. Whereas rather than moving in this particular form from one initial position to the other initial position, whatever is the shortest, whatever is the smoothest possible path planning, that will be done in the trajectory optimization technique with the help of the mathematical optimization. Right, when we come across the hybrid, the main advantage of this is multiple methods. In hybrid, we have multiple methods, like different strategies. When we combine all the different strategies, depending upon the possibilities, depending upon the requirement of the company, depending upon the requirement of the industry surrounding, we can combine any of these particular algorithms, and that comes under the hybrid approach. It is the advantage of multiple methods or the different strategies when it comes along together is known as a hybrid approach. Right? So these are the three types of the path planning algorithms which can be inserted in the robo, right, for its path planning destination. Next, we come across the challenges. What are the different challenges which a robo has to face when it is planning? One is the real-time requirement, one is the uncertainty, and the a major one is the high-dimensional C-sharp. C-shape is nothing but complex robo. C-shape means when we come across the complex robo, or when we come across different the robo which is having high degree of freedom, or when we come across a major bulk or heavy robo, the planning has to be done properly. It should have a higher dimension, and when the planning is to be done correctly for any particular complex part, this particular type of the challenge will be accepted. That is, high dimensional C-shape challenge should be accepted for higher degree of freedom type of the robo, or for any particular complex type of the robo, high dimensional C-shape challenge should be accepted. Next, when we come across the dynamic environment, that is real-time requirements, means what? When we come across the real-time requirement of the industry or the company, or when we come across the dynamic environment, we use this particular type of the challenge. Right? Next, when we come across the sensors and models of the robo, then uncertainty will be done. That is, sensors and models may introduce uncertainties that need to be accounted for the path planning. Next, where these particular path plannings can be applicable? What are the applications of this particular path planning? One is the autonomous vehicle, industrial robot, and service robot. Autonomous vehicles means what generally? That is navigating the roads. When we need to navigate the roads, or when we need to come across, when we need to avoid the obstacles and reach the destination effectively, then the autonomous vehicles will be there. We use this particular autonomous vehicle, and this is one of the application of the path planning. Next, when we come across the industrial robo, in order to have different paths between location within any industry or any company or any factory, while avoiding the collisions with equipment and workers, we come across the industrial robot. Whereas the vacuum cleaners or navigating from home environment, we come across the service robots. So these are the various applications of the path plan, that is autonomous vehicles, industrial robots, and service robots. Next, what is the future of this particular path planning? Where else can we use? Other than the previous three applications, where else can we use this particular path planning? That is, generally we can use in machine learning. When we need to collaborate, when we have to use a collaborative robots, there we can use, or for a human robot interaction also, we can use this particular type of the path planning. That is, using the machine learning algorithm to predict and adapt the complex environment, we can use this machine learning and machine learning in path planning, right? Whereas when we need to ensure the safety and navigation efficiency in the environment with the help of human, then we need to come across the human-robot interaction. When we come across the coordination and communication, then we come across the collaborative robot. So these are the future trends of the path planning in the robo, where these will be coming in the upcoming industries or upcoming companies in the higher model. Right? So overall, the path planning is nothing but it is the planning to be done to navigate from one point to the other point, where the planning has to be done periodically depending upon the environment constraint of the factory, or depending upon the idea of the obstacles being placed in between the factory inlet, the path planning has to be done. So generally the path planning is used to navigate from one point to the other by efficiency and safety, by its efficiency and safety. Whereas we have included machine learning also in the upcoming feature, where it is used to handle increasingly complex and dynamic. When we have increasing complex and dynamic environments coming further, there we can include machine learning being imparted in the path planning in the robot, right? Whereas the other things are optimization, as we have discussed earlier in the trajectory optimization, autonomous vehicle, all those constraints also this particular path planning will be used. So this is all about the path planning concept, how a path planning has to be done, what are the various applications, what are its future trends, what are the different types of path plannings we have seen, that is local and global, what is the difference between those particular local and global path planning, all that we have discussed, and what is the difference between a trajectory planning and a path planning we have discussed in today's class. Hope you have understood. Thank you. Signing off for today, Dr. G. HimaBindhu.
Like, share and subscribe. Hit the bell icon for more updates.